minutes to go through this briefing, and you're not going through all the things that they've already learned about for normal circuits and the circuit considerations. It should just focus on what is new. Don't repeat everything. It's about 25 minutes. Before I forget, Jess would like to start your solo briefings at 12:30, so if we get through this as quick as possible, then you can have lunch, and 12:30 she wants to start, but she's got to leave a bit earlier. So what we're really looking at today, already in the circuits, you have had to deal with some crosswind. We've had to deal with crosswind on the crosswind leg, and the downwind leg, and the base leg, and you've learned how to correct for that so that we still maintain correct spacing and keep flying towards our reference point. So what we're really talking about today with regards to crosswind is the takeoff and the landing. This is what is new in today's lesson, in today's briefing. Here's our objectives. A couple of things we're going to recap on. How to correctly position the aircraft's controls on the ground, as you learned way back when we did taxiing. So this is where I'm definitely transferring that responsibility over to you today. And I'll expect that in any conditions you're always appropriately positioning the controls. You've already been doing this as well. There'll just be a little bit more to discuss in relation to taking off and landing today. And this is the new stuff. So it starts with a little bit of a recap on the control quartering. Before you bring up this slide or the following one, maybe pause here and ask some questions. Gauge whether or not they can remember what the control quartering is. Give them some examples, I don't know, hold the model up and get a blue pen out and say the wind is coming from here or something, or you're taxiing along hotel and the wind's coming from behind you. How would you position the controls? You don't have to go through every single scenario, okay? But if they can get a couple right, then there's a good chance they actually do know what they're talking about. And of course, you'll assess that in the flight as well. But the general principles, remember, is that we climb into wind and we dive out of wind. So ask some questions around this. Be prepared to guide them back through this if they don't understand, but they should be familiar with it. You could even say to them, no, disregard that. So further considerations. Each aircraft is given a maximum demonstrated crosswind component by the manufacturer, and you'll find this written in the limitations section or in the performance section of the flight manual. For a DA40, that is 20 knots, but it varies from aircraft to aircraft. This is just the maximum crosswind that the manufacturer has tested the aircraft in and has determined that you can take off and land straight. That does not mean that the aircraft cannot handle any more crosswind than that. We actually know that typically they can handle a lot more. It's not a legal requirement to stay inside this limit, but it is certainly a consideration. And hey, we're not going to go anywhere near 20 knots of crosswind at this early stage of your training. We're going to gradually expose you to stronger and stronger crosswinds across each of the different semesters. And so by the time you're a fully fledged pilot, you should be able to deal with a 20 knot crosswind in the DA40. We do what I like to call exercise your comfort zones. So you will go up with an instructor in stronger crosswinds, and you will practice dealing with those stronger crosswinds, gaining the skills and the confidence in a controlled and safe manner. You do not want to find yourself flying in conditions outside of your own personal minima. You could mention the crosswind component for the different aeroplanes that we have here. 17 knots for the twin, 20 for a DA40. I don't know what Fox is. What is it, 15 or something like that? Maybe brush up on that before you do your TR3s. So it's different for each aeroplane, but our personal minima is really important here. Just because the aircraft might be able to handle that doesn't mean that we as the pilot can. So we must develop awareness of how much the crosswind is and make a decision about whether or not we're going to go flying today. So in that sense, we have to calculate the crosswind component. next couple of slides. Hey, what are the different places that we could get wind information? Ask them. Another click brings all of these up in one go. Mention all of these. Talk a little bit about what is in degrees true and what is in degrees magnetic. A classic error of a student is to use the wind in a TAF or METAR and not convert it to magnetic. Classic. And all of a sudden, you've either got a crosswind that is stronger than actually is, or weaker, and you're not expecting it, and you've made a decision to go flying because you've calculated the crosswind was within your personal minima, when actually it's a lot stronger. So make sure you teach them to convert these figures. The way I sort of think of it is anything written down in forecasts is in degrees true, and anything that is verbally stated, such as ATIS or by the tower or an AWIB, is going to be in degrees magnetic. And the windsock can also be really helpful as well. In some cases, it is the only way to determine how much crosswind there is. Say, for example, Foxbine, we've got no AWIB, we've got no ATIS, there is no METAR, there is no TAF. Sure, we might look at the nearby TAFs and METARs and maybe get a bit of an idea, but by this stage, the student's probably gone out to the southern training area and realised sometimes it's complete opposite runway in use in Foxbine, and sometimes there's a screaming crosswind and there's no wind in Palmy. So it does change even over a short distance. After that, it just goes through the different methods. You don't need to go through every single method. The ones in the briefing, yes, tick those off, but like you can calculate this on your Pooleys or your Jepson or like on a calculator. You don't have to go through that stuff. Mention though that it's one of the ways, because it's up to the student really to decide. So here we're wanting to land on a runway today, 07 at Palmy, and the wind is not aligned with the runway centre line. There is some crosswind. So we have all of these things available to us to determine how much that crosswind is and to make a decision as to whether or not we will fly today. In the flight manual, there's a graph which we'll look at shortly that determines how much headwind or tailwind and how much crosswind there is. That's quite useful. We could use a navigation computer. I don't personally remember how to do that, but maybe you do, but I would suggest you don't have to remember how to do that. ATIS will often state how much crosswind there is, but don't forget with the ATIS, sometimes it just gives you a mean or a max crosswind, not necessarily exactly what it is when you depart. And the ATIS isn't always updated as frequently as we might like, so that information might be out of date. So don't just use the ATIS alone. Or what we could do is ask ATC what the crosswind is doing. That's another idea. And the windsock. We need to become familiar with what the windsock might look like in different crosswind conditions. So here's that graph. If the student struggles to see it, you might have to adjust the lighting or whatever, but I believe you can either run through that example or there is one in the speaker notes which says wind is 280, let's just say magnetic, 280 degrees magnetic, 20 knots. So give a bit of an overview. I mean, you should know how to use this. I'm assuming you will know how to use it, but give a bit of an overview of what's actually being shown here, because this may be the first time they've ever seen it. So we've got headwind component or tailwind component along the vertical axis, and then we've got the crosswind along the horizontal axis. Each of these radial arcs represents wind speed in 10 odd increments. So we've got 10, 20, 30, and so on. Each of these straight lines going out from 0 represents the angle between the runway heading and where the wind is coming from, so the angular difference. So if we have a look at our example, 280 degrees, 20 knots, which runway do you think you'd use? So ask that question, hopefully 25, and we can determine how much crosswind there is. So what is the angular difference between the runway heading and the wind? You don't need to spell this out, get them to do it. Even get them to come up here with an electronic whiteboard pen and fill it out as you go. It doesn't work very well on this thing, but the thick one does. So we're looking for 30 degrees, so that straight line there, and we're looking for 20 knots, so this arc here. So what we can do is draw a little cross or a point where the two intersect, and then we draw a horizontal line across, which will tell us our headwind component, and a vertical line down, which will show us our crosswind component. And I believe, yes, here we go, another click, will actually bring those two components up. So for wind that's 280 degrees, 20 knots, we've got about 18, maybe 17 knots of headwind there. Quite a lot of headwind, because the wind isn't that far off the centre line. And we've got about a 10 knot crosswind. There's a reasonable amount of crosswind there. The two components don't have to add up to the total wind, and they often don't. So don't think you've done something wrong if the student asks, oh, hang on, why is this 10 and that's 18? That doesn't add up. It doesn't have to. So this is probably something we'd more use on the ground before we depart, because we have the time to actually get a copy of this out and do that. Otherwise, in flight, we'd have to grab it out of the flight manual and then run through the calculation, which we could do, but there are quicker ways of determining the crosswind and more practical ways than having to grab out this document. So that's what we'll talk about. Like I said, at Foxpine or some other aerodromes, we don't have forecasts or reports or TAF or META or ATC in attendance, so we may have to learn to interpret what the windsock is showing us. This is a 25 knot windsock. There are different types. There are 15 knot windsocks. In fact, at Foxpine, you've got a 15 knot one at the eastern end, and you've got a 25 knot one at the western end. So it's harder to see the 15 knot one as well. If the windsock looked like that, that would be approximately 30-degree angle between the mast and where the windsock is orientated, and that would suggest to us that they're up to 8 knots. And then you can work your way through all of these, okay? This one here is 25 knots plus, because of course the wind could be stronger than that, and especially if it's flicking up and down, that would be stronger than 25 knots. So this is a useful technique. In some cases, the only technique. This one is the one I typically use myself, the sine method. Forget about sine, you know, we don't need to be mathematicians or anything. I usually just write up the rule for them. Let's do it as percentages, eh? So then you can explain this. One really helpful technique is to figure out the angular difference between the wind direction and the runway heading and how strong the wind is. And then we can use this rule to determine how much the crosswind will be. So if it's 30 degrees off the runway heading, 50% of the wind will be crosswind. If it's 45 degrees off, blah, 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 blah. Okay, work your way through that. Effectively, when you get to 60 degrees off, it doesn't mean that there will be no headwind. It means, though, that there's going to be a lot of crosswind from that point on. There is actually a rule you can use for headwind as well. It's not in this briefing and it's not necessary, and I can't remember it, but there is a similar rule you can use for that. This is useful because when you've got an A-wind, like in Hawera, you can listen to that 20 odd miles before you get to the aerodrome, and you can determine which runway you're going to land on and how much crosswind there will be, whether that is within your own personal limit, right there, even before you attempt to land. On this slide here, you're introducing some of the big differences, okay? Often in crosswinds, especially in Palmerston North it seems, not only is there crosswind, but there's also really gusty conditions. And really, we usually have no crosswind, or we have a screaming crosswind, 25 knots from the southeast, horrible, bumpy, wind shearing conditions. So if we do have those kind of conditions, or the crosswind is very strong, we may elect to adjust the rotation speed as well as the approach speed to allow for any gust factor. And the typical rule of thumb is to add half the gust factor onto your speeds. So if there's a gust factor of 10 knots, add 5 knots to your rotation speed with your approach speed. The reason for increasing your rotation speed is a couple of ones. One, to allow for any sudden losses of airspeed once you get airborne, which could cause the aeroplane to stall. The second reason is to ensure you get a smooth liftoff and away from the surface as quickly as possible. When the aircraft does become airborne, it will weathercock or yaw itself into the oncoming airflow. And this creates a sudden increase in drag, which could cause the aeroplane to settle back on the runway as it's going sideways. Not good for the undercarriage. So a slightly higher rotation speed can eliminate the risk of that actually happening. The approach speed is more of a wind shear consideration, but also the rudder is the primary control to straighten up before we land. What happens to the effectiveness as we slow down? Yes. Yeah, so they'll know that. So not an issue when we're in the air, but when we're rounding out, throttle's closed, airspeed's reducing, the rudder's effectiveness is reducing. So really highlight here that as we do slow down in the flare, more and more rudder or more and more aileron sometimes is going to be required to actually keep the aeroplane straight and on the centre line. This is a big fault of students, is they do straighten up initially, bring the throttle back, yep, it's nice and straight, centre line, and then they make no other changes, and then we end up landing near the grass on the side of the runway with the nose wheel no longer straight. It's because they forget that you've actually got to put more and more input in, so typical fault, okay, so really emphasise that. Lots of decision making required. Crosswind can mean less headwind, and as we've just discussed, we potentially have a higher rotation speed, a higher approach speed. We may even elect to use a reduced flap setting for landing. When you extend flap, you create frontal surface area, and the crosswind will create more drift if there is more frontal surface area exposed to that wind. So what do we have to think about? Which runway is actually going to be appropriate for us to land on? Would we actually want to land on the 600 metre grass runway with higher approach and rotation speeds and a reduced flap setting and less headwind? No thank you. So we may have to elect to use a different runway if there is a strong crosswind. We must always ensure that there is a safe distance. Situational awareness is important throughout the circuit. So you need to constantly assess where the wind is coming from, how strong it is, and what effect it is having on your flight path. You should still be flying a standard circuit in the sense of standard circuit spacing, still turning downwind at the same place, just as you learned in the circuit mass brief and circuit lesson. So we need to be aware of what is happening to the wind. It can be a little bit stressful dealing with crosswind. The issue is with regard to the takeoff and landing that not only now do you need to round out, close the throttle and fly level with the runway, now you're also going to need to straighten the aeroplane up and maintain the centre line with ailerons. So there's a little bit more workload, it's a little bit more stressful. Hey, it can be gusty, very bumpy. So this is why we do a crosswind lesson, to give you the skills and the confidence to actually deal with this. And as I said before, we will exercise your comfort zones, your personal minima in a controlled, safe manner throughout your training here. I've kind of already talked about that point already. Don't forget, we can always go around. If it's an unstable approach, if we're high or low, fast or slow, or not on centerline, or if we're losing directional control of the aeroplane, we can always go around and have another go. And we'd have to think about, okay, why did that problem happen? Is there a way that we can avoid it happening again? Do we still land on this runway, or do we divert to a different aerodrome where there might be less crosswind? These are the kind of things that we'd have to think about in a situation where that is required. There's something else I was going to say, and now it's gone. Okay, so that brings us to the year exercise. So this is the new part, the takeoff and the landing, the technique required to prevent the aircraft from drifting. So tell a couple of stories here, okay, and you just work your way through this. So if we're in the circuit for 07, the wind is southeasterly, as it often is when we have a crosswind. As we get airborne, the aeroplane is going to want to drift. And so you could ask your student, hey, what's the aeroplane going to do? Where is it going to drift? Get them to come up here, or ask them, it's going to drift that way. This will create problems with the circuit spacing. So what do we need to do? Once airborne, we need to make a coordinated turn into wind in order to continue tracking towards our reference point out here, to track the extended centre line. You must emphasise, not necessarily on this slide, but in the other area exercise slides, it is a coordinated turn into wind, okay? So many times I see students just stabbing in rudder. That is a great way of causing the aeroplane to settle back on the runway or stall. So no, coordinated turn into wind. Then you can discuss the effects at the various other circuit sectors, on your crosswind leg here. They're used to compensating for the wind on that leg already, so shouldn't need to be too much discussion there, but now you've got a tailwind. Run through with them what that's going to mean. It's going to mean they get to that point there, that 45-degree angle, sooner than they would normally. And they may not be at circuit altitude yet. So this crosswind leg may be really quick if the wind is coming from out there. So we need to roll wings level on the reference point, good lookout, get ready to turn downwind at the same angle as always. Everyone should still have the same spacing. Again, the downwind leg was discussed in the circuits briefing, so no extra details needed there. More detail maybe here, around now we've got quite a strong headwind on the base leg, so what will be the effect? Base leg is going to take longer. That may mean we lose excess altitude. So what could we do about that? Well, there's no point bringing the power back to 12 inches there, getting to here and realising, oh, we're too low, and having to add 22 inches of manifold pressure back on. That's not very good piloting. So we learn to anticipate the effect of the wind. What could we do? We could delay the setup, maybe until we turn onto the base leg, maybe reduce the power on the base leg. Or we could not reduce the power as much, rather than set 12 inches, bring it back to something else, 18 or 16 inches. The choice is yours, whatever combination of power and position you want to use. Have a chat about the turn onto final here. Note how there's your nose position there to maintain a square base leg, and we barely even had to turn in order to maintain the centre line, so it's quite a small turn. So that turn can be delayed until you are almost on the centre line if the wind is coming from that direction. I'm not going to talk you through this one, but you get the idea, okay, the wind is now coming from that side, so this is going to change your the altitude you'll get to on your crosswind leg. It's going to change the altitude you'll lose on your base leg, and it's going to affect when you start that turn onto final. So you're going to need to anticipate the turn because you've got a tailwind, bigger radius, and that turn is going to be more. So this time, here's the nose attitude, and we've got to turn all the way around here, so the nose is still out into wind, tracking the centre line. So it's a bigger turn, bigger radius, so it needs to be started slightly earlier. Not talking about takeoff and landing technique on these slides, on this slide, sorry. So this is where we actually start building the takeoff and the landing stuff. We're lined up on the runway. We've made our decision that yes, there's a safe amount of runway to take off in this crosswind conditions. It's within our personal minima, so we're happy to go. We will start with the ailerons being fully deflected into wind to stop the interwind wing being lifted up in any gusts or strong wind. We don't want to lose directional control. And either a neutral elevator or a slight forward pressure. And this is really only to just ensure that a sudden gust doesn't get underneath the elevator and cause the aeroplane to rotate prematurely, which could cause a loss of directional control as well, or at the very least make it harder for you to maintain the centre line. pick a reference point. There's two camps here. Either one camp is you maintain the same reference points you always did, but you just adjust the heading to maintain it. That's what I tend to do. Or you pick a brand new reference point, but that reference point is the heading that you need to fly. Does that make sense? Like, there's two camps to it. It's your choice what you use. I find it easier just to think of the reference points as the aeroplane should always track towards them, and the heading can be whatever it needs to be in order to do that. Because after all, it is tracks that we're wanting to maintain in the circuit. So we've been cleared for takeoff, we're accelerating down the runway, those ailerons are getting more and more effective. What do you think might happen if we left full aileron deflection and two and two together? Oh, we start to roll. Yeah, you do start to roll, and you will lose directional control. So as we accelerate, the aileron deflection can be reduced to the point that when we rotate, the aileron should be neutral. We don't want to have any aileron input then, because we'll scare ourselves and rapidly roll when we get airborne. We want a positive rotation. By this, I'm not meaning rip back on the stick to get the airplane away from the ground, but a little bit more of a positive rotation than for a normal circuit. We do not want to allow the airplane to start slipping sideways across the runway. So typically what a student will do here is they'll rotate just very slowly, and like I said, when that nose comes up, the wind catches you and you'll start to drift, and so what does that do? All of a sudden the tyre is stuck and it scrapes sideways across the runway. What's the problem with that? Well, you could rip the tyres off, you could put extreme strain on the undercarriage struts themselves, but also, did I say tyre tread? Your tyre tread can be worn off as well, okay? So once airborne, we make a coordinated and gentle turn into wind to continue tracking the extended centre line towards our reference point. I'm going to skip over this slide because there's nothing I need to teach you there. There's nothing particularly new on this slide either. Honestly, whoever made this briefing never bothered to put some speaker notes about what they were meaning by a normal base approach. I have no idea why that's even in there, but like I said before, you adjust the power setting to suit the wind conditions, okay? So maybe you set up later. You should still stay on profile, and that's probably what is meant by a normal base approach. One thing to really teach your students here, it's not necessarily on this slide, but I've just remembered it. You do not want a student to get low on approach in these conditions, okay? Because the lower you get, the more wind shear you'll encounter, that mechanical turbulence, the rougher it will get, and the increased likelihood of you actually stalling. So never be low on these kind of days with a strong, gusty crosswind conditions. I often, if anything, come down a little bit steeper, come down a little bit above profile, because often if there's a strong crosswind, there's usually a pretty strong headwind as well. Not always, but sometimes. So some of the stuff we've already talked about, okay, I'm not going to run through this again. Anything new here? So on final, it will be necessary for you to crab the aircraft in towards the runway. So it'll appear that we are flying sideways through the air. We may actually be looking out of a side portion of the windscreen at the runway. So we position the nose into wind to maintain the centre line all the way down to our touchdown point. Mentioned before, we may elect to increase the approach speed if it is either a really strong crosswind or B, a gusty wind. And we may also elect to use a reduced flap setting. But my 50 cents on this is, I think people rush to use a reduced flap setting. It's not required if the crosswind is steady. Like, the manufacturer tested this aeroplane in a 20 knot crosswind and the landing flap configuration. So I don't agree with students sometimes when they say, oh, there's a 10 knot crosswind, I'll approach with takeoff flap. Gusty, sure, you know, I'm a bit more open to that. Or a really strong crosswind, yeah, I'll be open to that as well. What you be careful of, particularly if you are using landing flap though, of course, is you may be approaching faster. Now you've got a smaller buffer between your approach speed and your actual landing flap extension speed. And maybe you can relate to this, but it's so easy to exceed that landing flap speed in those kind of conditions. So as an instructor, you've got to be really disciplined in making sure they are onto it with their speeds. So the actual technique itself, so we're using runway 07, and we've determined that there's a crosswind coming from the right, and we're on final, KDP5, we're on speed, centerline and profile. Always check the windsock. No matter what kind of landing it is, always check the windsock at KDP5 so that you can brief yourself on what you're expecting to do in this landing. You know, again, a tangent, but it really annoys me when you say to a student, show me a flapless landing, excuse me, or show me a short field landing or glide approach or whatever. And they do all that fine, but they totally forget to make any correction to the crosswind and we land sideways. Not okay, and like at a CPL level, people fail CPL tests for that. If there is a crosswind, you are expecting the student to make allowances for it no matter what kind of landing or takeoff it actually is. Make sense? Just really instill that in them. So coming down to the aiming point, it's rising up to meet us. We need to straighten up the nose wheel. Straighten up the aircraft nose with the centre line, and we use rudder for that, sufficient rudder. Now, we've solved one problem, we straightened the nose, but look, we've drifted away from the centre line, so this is no good. Solved one problem, there's still another one we've got to solve. So now, we'll have to use aileron to maintain the centre line. Aiming points coming up to meet us, we're straightening up and we're applying inter-wind aileron. We're actually lowering the inter-wind wing here as well as rounding out in order to maintain the centre line. Now how much aileron do you need to use? It depends on how strong the crosswind is. But as we slow down, you will find more and more rudder is needed. More and more aileron is needed as well. So then it just goes through an example. Here we are at Fox Spine. Thank goodness the trees aren't like that anymore, because I wouldn't want to go in there on a day with a crosswind like this with those trees. Coming in on final there, coming to the round out, straightening up with rudder, maintaining centre lane with aileron, and once we've touched down, increasing the aileron deflection to stop that inter-wind wing actually from being flicked up and losing directional control. This is really just a very brief discussion. The method we use is what you could call a combination method, because we're using a combination of rudder and aileron. It's the easier method for students. It's still tricky, to be fair, but it is far easier than this kick straight method, okay? This requires very accurate timing. So the only difference here would be, rather than use any aileron, the aeroplane is flown in a crabbed position all the way down to the aiming point, and just prior to touching down, rudder is kicked in to straighten the nose, and the aeroplane is promptly touched down on the runway. No float, because if there's any float, you're going to drift off the centre line. Requires very precise timing, and so much harder for a student. It's not that it's wrong to teach them, but it's not a standard thing we teach, so we do the combination method. We've discussed this slide about going around, so really just emphasise to them again, we want a stable approach. Go around if it's unstable, or if we're losing directional control. The landing roll itself, talked a little bit about this stuff first. What they'll forget to do is they'll forget to round out. They'll straighten up, they'll maintain the centre line, but they'll forget to either bring the power back to idle or forget to round down and you'll bounce, and then you'll need to go around. Expect that to happen. That's okay, they're learning. Have another go at it. We touch down on the inter-wind wheel or upwind wheel first, then the other main wheel comes down, and then we can gently lower the nose wheel. You don't want to hold the nose up off the ground, because that'll increase the likelihood of losing directional control. You may find in the landing roll, only if we're coming to a full stop, that brakes, asymmetric braking has to be used in order to maintain the centre line, particularly if it's a very strong crosswind. Not in a touch and go though, okay? We're not touching those brakes if we're doing a touch and go. Landing though, full stop is absolutely fine. Don't slam them on though. And look, if you are doing touch and goes, ensure that there's a safe runway still remaining and that you're actually on a safe place on the runway before you set full power, because inevitably when they're learning, they won't be on the centre line, they'll be close to the grass on the side. Don't do this at fielding, with them. Do it on a wider runway initially until they're a bit more practiced. There may be value in also not doing touch and goes, doing stop and goes or stop backtrack and goes, because when you actually do touch and go, you're not applying more and more aileron as you slow down, right? You're not getting much practice at that. So for the first few, when I teach this to a student, I get them to just do stop and goes on the main runway because there's heaps of space. But then we go to touch and goes. That's your discretion, but that's what I find valuable. That's it. So lots of discussion. Emphasise the new things. You do not need to go through the whole normal circuit pattern again. Take a look at the CAA Flight Instructor Guide and what they have on crosswind. I probably mentioned this already, but I like the CAA Flight Instructor Guide because it gives you some inspiration on how to introduce a topic, and it also gives context to why things are taught as well. So if you're ever struggling to think of the whys, that's a good one to go and have a look at. Do you have any questions about anything?